Hey guys, you should be doing this kind of on your own unless there's technical difficulties, and then the sub may have to play it overhead. But we are going to cover rock cycles and weathering and erosion. This should be review from 5th and 6th grade, but if not, remember when you take notes, write the stuff that you don't know, that's new, or that you've never seen before that you get confused with. So let's get started talking about rocks because they kind of rock. There are three main types of rocks, igneous, metamorphic, and sedimentary. Each of them form in a very different way. So we're going to talk about how they form and what makes them different. But before that, let's look at weathering. And I don't mean like weather in the atmosphere. I mean weathering like the breaking down of rock material. So on Monday, we did a quick hand gesturing. So this is the pounding of your fist in your hand to mimic the breakdown of material. If you look at the picture, the weathering that's done there is done by wind and probably a little bit of water, but weathering usually takes a very long time. So breaking it down a little bit more, the three main types of forces that break down rocks are physical, chemical, and biological. So there's Mario in the lower right-hand corner to help you with the breakdown, that pounding of the fist. Physical weathering is the first type. It is either when hot and cold temperatures change and it causes the rocks to expand and contract, and over time that expansion and contraction causes bits to fall off. Rain is another physical weathering force, and when rain falls, if it freezes between the cracks, it goes back to that expand and contract, and the rain freezing causes cracks, and then over time the cracks become large, and then eventually they fall off. The last one on this slide is wind. Wind, it says softly pulls rock pieces. If you think about wind, if you've ever been outside when the wind comes through real fast, you get like little bits of dirt in your eye. If you can think about those little bits being pulled off of rock. So the bottom right-hand picture is done by wind, and you can see how it kind of is jagged. There's no real formation usually. It can pull different pieces on different sides of a rock depending on where they fall. The one in the left-hand side was done by wind as well, and you can see there's a specific kind of pattern there. Frost wedging. This is the freezing and thawing. This is when rain falls in a rock and causes it to crack. If you look at the top picture, you can see how as it freezes, it pushes the rock in different directions, causing pieces as the frozen water melts. There's nothing there to hold the rock on, so it falls away. The last part on this rain-based one is frost heaving. Heaving is like to push upwards. If you've ever been in somebody's backyard and it kind of looks like the picture in the patio in the picture, you can see that sometimes it's very uneven because all it takes is a little bit of water to get underneath and freeze and push it up. Chemical weathering. Chemicals, just like with a chemical reaction, when this happens, it is irreversible. I can't undo it. I can't make it go back. The chemicals tend to dissolve the rock. Water can dissolve it over time, but when it's mixed with these chemicals, it causes something called acid rain, and this is a very specific type of chemical reaction. The picture above is of Hercules, I think, or Mercury, probably Mercury, and you can see the water patterns as it falls down cause very odd, almost like burns in the statue's surface. Oxidation is another type of chemical weathering. This is when the iron inside of rocks combines with atmospheric oxygen and it causes it to oxidize. This is kind of like when you have rust in the chemical reactions. If you look on the picture to the right, you can see there's a little faint red color there, so that shows the rust or oxidation of that iron. Biological weathering is caused by biology or nature. The tree roots in the picture on the left force themselves between the rocks. They push the rocks apart. There's also stuff called moss and lichen that grow on top of rocks, and they force them to separate as well. So specifically lichen leave a very weak acid to help them burrow into the rock. It helps them push their roots deeper, and by this acid being applied, it causes the rock to break down. Here's some more plants and their roots. If you see the middle picture, this is where a tree was grown at the base of this structure, and as it's grown upwards, it's just kind of forced its roots in to give it some more support. The one on the left is through a wall, so you can see how it's pushed out through a crevice, and then the one on the right is on a stone wall, and the tree was planted very close to the stone wall, and then as it grew larger, it just kind of embedded itself into the wall. Some other types of weathering are friction and repeat impact. This is where water goes down and slowly pulls pieces off. This is slow. It takes a really, really long time. The rocks that are done this way, if the water was moving slowly, tend to be kind of rounded, like the picture to the right. If the water was moving shallow and quick, we get sharper, jagged edges. If you can think Grand Canyon. Acid rain is when compounds from burning coal, oil, or gas react chemically with the water in the atmosphere. As the water within the clouds starts to condense, the water falls as a chemical altered rain. The acid in this can happen fairly quickly. It speeds up the chemical weathering process. And then here's some pictures of what's happening. We've got George Washington with that kind of weird marble looking on his face. This is the acid rain, like drip patterns down his face. There's some trees. I know we're talking about rocks, but I just kind of wanted to give you a different picture to see. There's trees that have been affected by acid rain. The one below it is a side-by-side. It's about a 15-year difference. In it, you can see even the rock behind the statue has been weathered quite a bit by this chemical acid rain. And then the one on the right is in China, where they have a whole bunch of air pollution problems. And this Buddha, all the green that's on him isn't moss. It's actually a chemical reaction with the marble that it's built out of, reacting with the acid rain that's coming down. Erosion. This was when we took our hand and we swept it across the palm to show that the rocks are being carried away. This is a process where water, wind, ice, gravity move the rock and the soil to a new location. It's really specific that erosion is just the movement of the rock or the soil. There's a little picture showing you how he's moving across. As rocks are broken into smaller bits, they move easier. The movement happens one of four ways. Usually it's gravity, because, gravity is something that you can't get away from. This is when stuff falls to the ground or goes down a slope. Water, obviously, if it's in a river or a stream, it will carry it. Wind, we kind of talked about with the weathering. So if the weathering was wind-based, the erosion will also be wind-based. And then ice, the glaciers trap rocks in them as they melt and freeze over time. And then as they start to thaw, they move and they carry those rocks with them. So here's some glacier pictures. The one on the right is the actual glacier, and you can see the melting pattern, and it would move those rocks down with that kind of, it almost looks like brown and white water. And then the one with the guy in it is actually a scrape pattern. As the glacier moved by those rocks, it would have dragged parts of those rocks with it. Water and wind erosion, they're on the same slide because they kind of work the same way. With water, it's rivers and streams that move the rocks slowly. With wind, it picks it up in small bits or pieces and can travel at great distances. The top right picture is actually a windstorm in Nevada, I think, or New Mexico. It's got the Pueblo houses. But these windstorms move great amounts of sand and small rocks over huge distances. And then the dunes below it on the right you can see the wind patterns as they whip through those sand dunes. There's a couple mass movements. This is when erosion happens very, very swiftly or very, very quick. There's landslides, slumps, and creeps. There also can be, we'll talk about that later. The landslides, slumps, and creeps are the big ones. The sinkhole, that's the word I was looking for. The sinkhole that's on the top left picture with the house, this would be kind of like a slump where there's an air pocket almost underneath the water. Usually it's an area where there was water, that there's no more water to hold up the rock. So as it gets weakened, it just kind of falls apart. So this is when it just basically drops straight down. The landslide is the bigger picture where you can see it is what the word says it is. It's where the land slides because there's weakened structure underneath it. And then the creep, not like a creeper, but a creep is when the land moves slowly. This happens a lot on the sides of highways where they've built the inclines up and you see the grass. In the lower left-hand picture, you can see that there's trees that are beginning to creep down the embankment. Deposition, we're almost done with this part anyway. This is where we would swing your hand way over your head and slap it back down. This is the depositing or the laying down of new material, of the material in a new location. So this is where bits are dropped to a new location. This is the dropping off. They tend to be laid down in layers. The heavier particles drop first because they're heavy. Over time, these sediments will create sedimentary rock. So if you see the picture, the bottom one, you can see the bigger rocks are falling down faster and the little ones follow. So here's your picture of your rock cycle. If you need to pause it here and write down any of this or sketch it, do so. If not, you might have this from Monday in your book, so you may need to label some stuff, but this would be a good place to pause and get your information. I'm going to keep going. All right, so my 3 rock types. We have sedimentary. If you look at the picture on the top, you can see it's layers. These are compacted and cemented, or compaction and cementation, basically meaning that they are pushed together and then over time they are bound together. These form in layers over time. It is the laying down of material. The grains of sediment are cemented or kind of glued together with gravity because of the pushing. These tend to contain fossils or remains of animals and plants within the sediments as they were laid down. So if you look at the top picture, you can see there's like some kind of weird dinosaur and like a dog bone and a weird little snail. The bottom one shows how they were layered down, so you can kind of really get a clear picture of how they lay down. Here's some pictures of some sedimentary rock. There's the sandstone from the slide before, and it tends to be very clear, almost like lines within the rock. Then limestone that's down below, this one is found in houses a lot. And then shale. If you look at the shale, it looks like there's different layers of this rock. Even though it's a black rock, you can still see there's almost like a top, a middle, and a bottom layer. So even though they may be the same color, they tend to have layers that allow you to pull them apart. Here's 2 more pictures. You can see the one on the left, very clear lines in it. This has been shaped through wind, erosion, and weathering, so you can kind of get a feel for how this can create really beautiful pictures. And then the one on the bottom, this is a sedimentary rock that's been folded underneath a mountain, so that's why it's angled. But if you kind of tip your head, you can see the layers within the rock. Metamorphic. On the top, the picture's on the top, let's start there. If you look at the top with the red box around him, he has layers, but they're kind of squishy. They look like they've been kind of heated up maybe or left outside too long. Then there's the Power Rangers. We'll get to them in a second. So thinking about the squishy looking rock, this is a rock, a metamorphic rock, where the pressure has built up on these rocks so much that it's pushed the sediments down together. But heat was added. So with sedimentary, it's just laying down in the pressure. With metamorphic, I have to add that heat. This helps melt the rock particles together and causes them to be a little bit stronger. The lines are a little less defined. And if you break down the word, meta means big. The gamers know that you have like a meta character that you play. This is your big person or your big rock. And then morph means to change. So meta, big, morphic, change. That's why we have high amounts of pressure, high amounts of heat. This causes the rock to go through a big change. So here's some pictures. The marble, if you look, there's some lines. It kind of looks like it might have been in layers, but they begin to blur because they're the heat, so they look kind of melted. And then there's slate. If you look closely, you can see there are lines, but the lines are less defined, and they look like they've been blended together because of the melting. Igneous rock. This is one of my favorites. The igneous is pushed deep into the crust. Excuse me. The heat is so hot on these rocks that they actually begin to melt. Once they melt, they're called magma because they're below the surface. If you think Austin Powers and his arch nemesis, He does the fingers together, as I call them, the nerd hands, and he's like, with my liquid hot magma. If you break down the word, igneous is similar to the word ignite, and ignite means to start a fire. So there has to be an intense amount of heat to melt them. That's why we have the picture with the rock that is melting. There are two types of igneous rock. There's two options. If it's pushed up through a volcanic eruption, then it's called extrusive igneous rock. And if you think extrusive, kind of sounds like exit. And if you look at the picture to the right, you've got a little rock being thrown out through a volcano. This type of igneous rock, there's two main types that we look at. One is basalt, which is what makes up the oceanic crust, if you remember. And the other one's pumice, and that's the picture that's there, is a pumice rock. If you look at the holes that are there, these rocks are pushed out very quickly, so they tend to have air pockets in them, and they tend to look like they're really, really dry. The second type of igneous rock is if they're left alone under the ground, and the magma cools and it crystallizes. And crystallizes just where it becomes kind of shiny. This is called an intrusive igneous rock. And then intrusive has the word in at the beginning. And if you think intru or inside, these are ones that are left inside of the crust. And the two that we look at here are granite, continental crust, and then obsidian, which is the picture there next to it. And these rocks, because there's such a slow amount of time it takes for them to be harvested from the earth, they have a very glazed look, or almost like a wet. So you have the extrusive with bubbles and kind of dry looking, and then you have the intrusive, which are a little on the shiny side. We are almost done. One of the big laws that go along with geology is called the law of superposition. This has to do with the sediments and how they're dropped during erosion and deposition. If you take a rock sample, like if you look to the picture, if we were to go on the very top of this kind of mountainy looking image, if we were to dig straight down and take a rock sample and pull it up, the oldest rock is going to be the farthest ones from the top. So the farther down I go in my rock sample, the older the rock is. This is, if you think about your laundry bag, if you throw a t-shirt in on Monday and then on Wednesday you throw another t-shirt, the one t-shirt you put in on Monday is older and probably dirtier and stinkier than the one that you put in on Wednesday. So it's all about the layerings. The biggest thing to remember is that the oldest rocks are at the bottom of a vertical sample, or the up-down sample.